All right, hello everyone. Welcome to the last day of notes for chapter 17. If you didn't notice, your test will be on Friday, so make sure you are studying for that. But let's go ahead and finish our last section of notes. So today we're talking about calculating heats of reaction. So before we get started, I kind of want you guys to think of the path you take to go home from school, or maybe your path going from the grocery store to your house or whatever. So typically there's a couple ways that we can go from point A to point B. So for example, I can drive to work either by taking Boulder Highway, or I could take the 515 freeway and get off on Lake Mead. Either way will get me to the same location, but one path might take more energy or more gas than another path. So that's really kind of what we're talking about in this chapter, is recognizing that there are different ways to get to the same place, but it might just but you will end up getting in the same place at the end, right? So we've got numbered 57. So this is graphite on the left. This is what's in your pencil lead. And on the right, hopefully you guys recognize that as a diamond. So sometimes it's really hard to measure enthalpy change. So remember, that's the change in heat. So sometimes the reaction might happen really, really fast. Sometimes it might happen really, really slow. So for example, carbon is what these are made of. So graphite and diamonds are both made of pure carbon molecules. Graphite, pretty easy to make. It's a pretty fast reaction, while diamonds in nature can take thousands and thousands of years to form. In the end, they're still both the same thing. They're both carbon molecules bonded together, but the path that they took was very different. The graphite can form higher up in the surface of the crust, while diamonds have to form deeply buried in the Earth's crust. So even though they're the same thing, they took very different paths. So this leads us to Hess's law. So this is number 58 through 60. 58 through 60. Okay, so we can figure out the heat of reaction using Hess's law. Now, like said before, graphite can form very quickly. It's easy to study that, while diamonds forming in nature takes a really long time, and it's hard for scientists to sit down for thousands of years and watch it, right? So basically, what Hess's law of heat summation states is that if you have two or more thermochemical equations, you can add the heats of reaction to give the final heat of reaction. What does that mean? That's kind of like a wordy definition. So it's basically saying that if you know how much energy is needed, you can figure out how much heat it will need at the end to make that end product. So by using equations of things that are easier to study, that happen faster, we can use that to figure out something that might be more complicated or takes longer to create. So basically, Hess's law allows you to determine the heats of reaction by using known heats. So basically, with the diamonds versus the graphite is a lot easier to study, and they can use that data, that heat that it needed to change, and apply that to diamonds, so they don't have to view it directly forming, but they can get a really good idea of how much time, how much energy is going to be needed to make that diamond, for example, because they could study the graphite and how that formed, because they're the same thing, just with its slightly different internal structure. Okay, so this is numbers, actually this is the last slide, so 61 all the way through 65. And if you're still kind of like unsure of what's going on with Hess's law, it's kind of a weird thing. Okay, I will post a video that I highly suggest you guys watch. So basically, going with this Hess's law and heat to form things, we look at the enthalpy, right? So we look at, scientists try to create the same conditions, kind of like with STP, right? So if you have a mole of something at a certain temperature and a certain pressure, it's a lot easier to study. That's the same thing with heat and seeing how things change. So what they call it is standard state. So basically they keep something at 25 degrees Celsius and at 1 atmosphere, which is about sea level, the pressure that you feel at sea level. And so to study the conditions, they have 25 degrees Celsius, 1 atmosphere, and then they can study that reaction and then apply that to other things that are similar to that reaction. So all of this leads to something called the standard heat of formation, and it's written as delta H, so change in heat, F formation. So it's basically if you have a mole of a compound, if you're trying to change it into something else, the amount of heat that's needed would be your standard heat of formation. So with Hess's law, oopsie, sorry, we can look at this. So there's multiple paths that you can take to figure out the heat needed to change a substance. So one way is to just sit around and watch it happen, and who knows how long that's going to take. Or we can study other substances, know what their reactions are at the standard state, and then use that to make a really, really great hypothesis, I guess, not a guess, but hypothesis of how that's going to react, even though it might take too long to watch it react. Like the diamond and the graphite, it takes too long for diamonds to form, but they can watch graphite form and then use that information. So anyway, that is actually all the notes for today. Not too long, so yay. So like I said, there is a video I do want you guys to watch that will be posted on my website, so make sure you're doing that. Do not turn in your notes yet. We're going to turn them in on the day of your test, just like we always do. And remember to be studying. Your test will be on Friday,